Now we're going to discuss motherboards. Motherboards, main boards, system boards, or MOBO. There is a lot of names for motherboards. But this is what provides the basic foundation for all computers' hardware, including the processor, the RAM, the firmware, the expansion cards. Everything has to run through the motherboard. So it is one of the most important components of your computer system. It dictates what you can add to it and what you cannot add to it. It can dictate how much RAM can actually be used in your computer. It can dictate all the technologies that you may be able to put in or you're not able to use. So just make sure you keep it in mind. There's a lot that goes on here. All right. So as we see the motherboard picture in front of us, we want to start studying the components on the motherboard itself. When you're having a test on this, there's more likely you're going to have a drag and drop scenario where they're going to point to certain things on the motherboard as you see here. And then they're going to have names on the left-hand side, and you have to drag and drop the name to the part. So right off the top, we can see we have PCIe, Peripheral Component Interconnect Express. PCIe is the de facto standard for our expansion cards today on our motherboards. Now, they come in different speeds, and we'll cover some of this in a later chapter, but you may see it. It looks like an X. It'll say by 4, by 8, by 16, by 32. It's telling you the bandwidths and the speed increase on each expansion port or slot. We can see that there's PCI by 16 are these longer ones, and they have a little thing that I like to call a flipper. Looks like it has a flipper on it. And that is to catch the card in the back, and they're going to be primarily used for your high-end expansion cards, such as graphics. We also have our DIMM slots. This is for our memory, and this is where our RAM goes. This is our computer memory that's going to be placed. We have a socket. The socket predicts what type of processor can fit into the motherboard. This is an LGA 1151, which allows for Intel Core processors. This is where you can put your i3, i5, i7, i9, whatever you have can fit into this particular socket. Along the backside, we have all these ports and connections, which we're going to cover in a little while. Moving on. So there are a lot of different motherboard standards. Thank God we don't have to learn them all for the exam, but we do need to know ATX is the largest motherboard, which allows for the most expansion. It's 12 by 9.6. Now, memorizing the sizes are not going to be for the exam, but they are going to help you physically locate and see what type of motherboard it is before you even touch it. So if it's 12 long by 9.6 wide, you know it's an ATX because it's longer than it is wide. A micro ATX is going to be 9.6 by 9.6. Same height and same width. Easy to see and understand. And then we have one called a mini ITX. ITX is for your small form factor or slimline cases, and that is 6.7 by 6.7. So you can see, as we learn and progress through this class, you should be able to start identifying motherboard types and features just by going over chapter 1. Now, there are other ITX-based form factors, and these are going to be for the smaller mini ITX. And this is really boards that are used for embedded systems, like time card machines or security surveillance systems. These are designated motherboards that only are really made for one function and produced by a variety of companies. Here is a good shot of all three major motherboards next to each other. So let's review. We have our ATX, 12 by 9.6. We have our micro ATX, 9.6 by 9.6. And we have our ITX, which we like to refer to as mini ITX, 6.7 by 6.7. These three are what you're going to be tested upon, plus they are basically the three primary motherboard sizes that you would deal with when purchasing. Now we're going to look at some connector types on the motherboard itself. With the motherboard, we have the all-important CPU socket. The CPU socket predicts what type of CPU you're putting in. We also have our memory slots. These is what allows us to put and upgrade memory on our computer, which we refer to as RAM, random access memory. We have our disk controllers. Our disk controllers are how we interface or connect with our hard drives. This could be SATA, it could be M2. We have older style, which are called parallel. So we'll get into all of them and refer to them. And the front we can finally see here is where our input-output ports are. Now, ports are pretty much integrated on the machine. What do I mean by integrated? They are soldered onto the computer. So you will have USB, DVI, HDMI, VGA. They're all for connecting to monitors and displays. You have your sound. We'll learn all about which each color represents and things of that in future classes. But we know that these are permanently placed on the laptop or desktop motherboard. So quick question out there for you guys that have already worked with machines. What if I'm working on this motherboard and, oh my God, my sound right here. This stops physically working. What do I do? Now I have no sound on my motherboard. What can I do to remedy this situation? Think about it. Think about it. I can't hear you. Okay. What can I do? I can go in and disable that piece of hardware through what we call Device Manager or through the computer's BIOS. Once I shut that piece of hardware down because it no longer works, I can introduce a new sound card via a PCIe slot, which is an expansion card slot. Once I plug in the new card, I apply the software driver. That is the small program that allows the card to communicate with the operating system. You must have the right specific driver for each piece of equipment. We will cover all this in detail in later chapters. Then I can go ahead and have, voila, sound again. So I can play beautiful music with my friends. All right. What are we looking at here? Oh, a nice high-end motherboard. Now, this is a fairly brand new motherboard, and it has a lot of different features you may not see on most boards, such as the VRM, Voltage Regulator Module. So when a motherboard has a VRM, it literally allows the power to produce two different types of voltage for, let's say, two different processors. Some motherboards will actually support two processors, which is called SMT support, Systematic Multiprocessing Support. But the VRM allows two processors that may require two different voltages to receive those voltages. We also have our USB and HDMI. So up here, we have our plugs in that we're commonly plugging peripheral devices in and out with. We have our audio. And here's the first time maybe a lot of you have seen what an M2 is. An M2 slot is a newer type of hardware form factor for hard drives. So as weird as it looks, this is just a plate that's covering the M2 slot itself, but it looks like a stick of memory. And that's where the actual hard drive looks like a bigger piece of stick of memory will be placed onto the motherboard, and it's referred to as an M2 slot. Excuse me. We see our PCIe slots. So again, we're getting more and more used to what these look like. Notice there's a lot shorter ones and a lot longer ones. So there are different sizes for different types of expansion cards. But remember, PCIe is your de facto standard for all of your expansion cards today and moving forward. We have a thing called a chipset. A chipset is a very important part of a motherboard that, unless you're an IT tech like we are now, you probably never heard of. But the chipset works in harmony with the CPU. And think of the chipset as a traffic cop. Stop, go, slow down, speed up. That's what it does on the motherboard. It takes all these different speeds and data requirements, and it regulates the flow in which the motherboard communicates. We'll talk about that in more detail and more specifically in a later chapter. Now you finally see the SATA ports right here on the side. The SATA ports are to connect hard drives that connect via SATA. This is a hard drive that connects via M2, looks like a credit card, stick of gum. And then we have our SATA port, which is our common solid state drive connection. This is where your drive will connect via one cable, a 7-pin cable, to one port. One port can only supply one hard drive, one device. Here are our DIMM slots. DIMM is where our RAM goes, our memory. DIMM stands for dual inline memory modules. That is the actual circuit board chip that all RAM is produced on. So the slots are called DIMMs. DIMMs, again, have all different types of keys and notches. So depending on the type of RAM that your motherboard predicts you use, it may be different amount of keys and notches on the RAM itself. This way you don't make a mistake and try to insert RAM that cannot be supported on your motherboard. So these DIMMs are, in another term, keyed. Keyed meaning you can only put them in one direction and they only accept the correct type. Now this is a lot of information. I want you to come back here, pause it, review it, and get comfortable with the visual. Everything that you learn from me is going to be visual, and then I'm going to try to give you some hints on how to remind you and memorize some of this information.